We've reached the end of another unit, so let's get going on this practice test for Unit 7, all the normal instructions. And then for these first 9 problems right here, it just says simplify each expression. So let's go ahead and simplify. We've got some distributing to do right here. I'm going to make sure I get all 3 of those pieces. I'm not going to multiply the 2x squared by the 3x out in front because this is not in the parentheses. That 3x times this stuff is only the stuff in parentheses. So what we're going to get here is 6x cubed. Multiply the coefficients together, and then this is x to the first times x squared, so we add the exponents. Then we're going to get a negative 12x squared. Then we get a 3x, and then we have this plus 2x squared hanging around there. The only like terms are these guys right here, so I'm just going to make sure that we write this in the correct order. So this is going to be negative 10x squared, and then we get the plus 3x. All in descending order. There aren't any constants in here, so we're just done with that one right there. And then we'll look through here. Again, these were a little bit tricky to get used to, but again, it's the same thing here. We're looking for the same variables and the same exponents, same base and same exponents. So if we look at these two guys right here, this has a 5 to the x, and this has a 5 to the x. So this is 4 of these things right here, plus 6 of these things right here. That would be 10 of those things altogether. So this is 10 and then 5 to the x. We talked before about the fact that you can put parentheses around this, or both of them if you want. It doesn't really matter. And then we ought to be smart about the way we write this. We ought to write the 5x first, and then we usually write constants at the very end. So we'll go ahead and leave that constant there. And then we've got a very simple problem right here, 2 to the x here, 2 to the x here. So I have 11 of these minus 4 of these, so that's going to be 7 of those. Go ahead and circle that. Coming down here, this is different. This is a multiplication problem. So remember, we multiply the we multiply the coefficient. So this is going to be negative 8. And then I've got 5 to the x times 5 to the x. So if that's the case, I have 2 of these multiplied together. If that's the case, then what I can do is I can keep the exponent the same, and then I can just multiply these together. So basically what I can do is I can say, look, I've got 5 times 5 to the x. Since both of those are raised to the x, I can just make a multiplication problem here, but then that ends up being 25. So we end up with 25 to the x with that negative 8 out front. Now, there are other ways to arrive at that. If you want to do it a different way, that's fine. We did talk about a couple ways, but that's the right answer right there. Let's take a look at this one. We've got a 3 on the top and a 12 on the bottom. They're regular old coefficients just like anything else. So I'm going to cross cancel this with this. 3 goes in here once, 3 goes in there 4 times. So we know we've got a 4 on the bottom. Let's hold off on writing the 1 there. So we've got 20 to the x over 10 to the x. So what we can do with that is similar to what we did over there. Since they're both raised to the x, we can go ahead and put the 20 over 10, and then we end up with a 2 to the x here. So this is 2 to the x on the top. Didn't need the 1. We'll go ahead and circle that, and we're finished. On this problem right here, very similar to what we had there. We've got a 12 and a 3, but slightly different order, and these two are now exactly the same. Since they're exactly the same, 2 to the x cancels with 2 to the x, because if I have the same thing divided by the same thing, we end up with a 1. And then do a little canceling here, we end up with a 4. Now remember, on the denominator there is a 1 left, but we don't have to write it if it's in the denominator. If this had ended up being 1/4, then we would have to write that if the 4 was on the bottom rather than the top. So just keep that in mind. Okay, let's take a look at number 7, 8, and 9. These are all binomials that we need to multiply together. So I'm going to multiply here and here, here and here. So 3y times 4y is 12y squared. 3y times 6 is 18y. 2 times 4y is 8y, and then 2 times 6 is 12. And just like normal, we have 2 terms here and 2 terms here, so we have 4 terms. These middle terms happen to be like terms, so we can go ahead and combine those together. So we get 12y squared, done with that one. Putting these together, we get 26y, and then we have that constant of 12 on the end there, so we'll circle that. Let's slide over here. Lots of negatives to keep track of here, so let's make sure that we're careful on this one. Negative times negative is a positive. X times x is x squared. Negative times a positive is a negative. X times 5 is 5x. We'll write it in that order. Negative times negative is a positive 7x, and then a negative times a positive is a negative, and that would be 35. Again, the 4 terms and the middle 2 happen to be like terms, so we're going to write down x squared. We're going to write down plus 2x when we put the 2 of those like terms together, and then we've got the minus 35 there. Circle that. And then this one's a little bit interesting because we've got an a squared term here. So we end up with 20 when we multiply the coefficients together. If I've got two a's multiplied together here and I times it by another a, that means I've got three a's there. So then I'm going to multiply here. That's going to be 24a squared. Multiplying here, that's going to be a minus 5a, and then multiplying there, that's a minus 6. And notice what we've got here. We've got a bunch of terms with a's in them, but they all have different exponents, and we've got that constant at the end. So that right there, that is the simplified answer. All we can do on that binomial multiplication problem is just do the multiplication. There aren't any like terms that we can combine. All right, let's slide down here. We've got some function operations to do. So on number 10, it says that we need to do f plus g and f minus g for each one of these. So let's run through and do this. So we need to add these together and then we need to subtract them. So let's go ahead and do f plus g of x. And again, this is just the standard way of writing this. So we're going to write 3x plus 1 plus 2x minus 3. Again, not a big deal that I didn't use parentheses because there's really nothing to distribute through. It's not going to change the sign of anything. So when we put those together, we get 5x minus 2. Circle that, that's the answer. If we do f minus g of x, this we do have to be careful with. We've got 3x plus 1, and then we're going to subtract each one of these. So when I distribute that through, that makes it a negative 2x, and that makes that a plus 3. So we've got that taken care of. Let's go ahead and see what we get here. That would be just a plain old x because 3x minus 2x is 1x. We don't have to write the 1. And then 1 plus 3 is 4. So we're going to put a 4 right there. Okay, next one. Same rules here. So we want to do f plus g of x. So we're going to have 3x squared plus 4x minus 6. And then we're going to add this stuff right here. So 4x squared minus 2x. And I'm showing tons of work here. Let's see what we get when we simplify here. Combine those like terms, 7x squared. Done with those guys right there. Combine those, we get 2x. Done with that. And then we got a minus 6 and a plus 10, so that's going to be a plus 4 altogether. So that's what we get when we add them together. And then when we do the subtraction, we'll have to be a little bit more careful with this. Here's what I'm going to do. I'm going to do 3x squared plus 4x minus 6. And then watch what happens. If I were to just multiply everything here by a negative, we get minus 4x squared. We get plus 2x, and we get minus 10. And what I'd like to show you here is all that we've done here by subtracting is we've just changed the sign of every one of those terms there, okay? Used to be positive 10, now it's negative 10, and so forth. Now we'll go through and put these together. So when we put those like terms together, we get negative x squared. When we put these like terms together, we get 6x. And when we put these like terms together, we get negative 16. And I'll go ahead and circle that, and that right there is the answer. Okay, same thing, but these have exponentials in them. So we're going to do f plus g of x. Gosh, I need to learn how to write here. There we go. So we're going to add these together. So it's literally just 6 times 3 to the x plus 4 times 3 to the x. So it's 6 of these plus 4 of these. So that's going to be 10 of these. So 3 to the x right there. And then if we do f minus g of x, it's going to be a subtraction problem. So it's going to be 6 of these minus 4 of these. So that's going to be 2 of these. Okay? So quick way to get the answer on that one here. And then same type of thing here. So we're going to be adding these together. So f plus g of x and then f minus g of x. Make that look right, even with the sloppy writing. We're going to add them together. We get 11. Ooh, let's take a look here. I misspoke. This is 5 2 to the x's and 6 3 to the x's. So these are not like terms. They don't have the base, same base. They don't have the same exponent. So we end up with 5 2 to the x plus 6 3 to the x. And then when we subtract them, we just get the same thing with a minus in between them. Okay? All right. So we are in good shape there. We've got all of those answers. Let's slide down and take a look at the bottom of the page. So we've got a multiplication problem with f and g and a division problem with f and g. So when we multiply these, so f times g of x, we're going to take 6x and we are going to multiply it with 3x squared minus 2x plus 2. So let's go ahead and distribute through here. So here's what we'd end up with. 6 times 3 is 18. X times x squared is x to the third. 6 times negative 2 is negative 12. X times x is x squared. And 6x times 2, that's going to be plus 12x. So we'll go ahead and circle that. Got our answer right there. Now we want to divide these. Okay, so we want to have f on the top. We got tripped up on that one time, so let's make sure f is on the top. So f divided by g of x. So that's going to be 6x on the top, and it's 3x squared minus 2x plus 2. Now I'm going to let you stare at that for just a second and see if we can simplify anything. Again, it looks like we should be able to simplify something like the 3's or the 2's or the x's. Remember, these are each terms, and each one of those is a factor. So we can't cancel a term with a factor. There are no factors down here, so we just circle this and we are done right there. Kind of cool when it works out that way. Okay, let's do f times g of x on this one. So we're just going to put these together, and we're going to multiply those. So a little bit of binomial multiplication here. And if we do f divided by g, let's see, let my computer catch up here. There we go. F on the top and g on the bottom. 4x minus 4 over 2x plus 3. Again, would be cool if we could cancel those. We can't because neither of those are factors. So we are done with that one right there. So let's just go ahead and pick this one up right here. Finish this off. We're going to have, let's see, 4x times 2x is 8x squared. 4x times 3 is going to be 12x. Negative 4 times 2x is negative 8x. And negative 4 times 3, that's going to be negative 12. And then we've got a couple like terms to do here. So we've just got that 1x squared term. We've got plus 4x. And then we've got minus 12. So we'll go ahead and circle that and slide down here. Take a look at this one. We're going to be multiplying these together. Interesting. So we haven't seen an x to the fourth before. So f times g of x, 10x times 4x to the fourth. Coefficients can be multiplied, so we'd end up with 40. And let's see, we've got an x to the first times x to the fourth. That's 1 times 4 more x's, so that's going to be x to the fifth. Done right there. Now let's pay close attention to this. So we're going to do f over g of x. So we're going to take f, which is 10x, and we're going to divide it by 4x to the third. Okay, this is where we get to put some of those tools to use here. This one can be simplified because 10 is a factor and 4 is a factor. So 2 goes in here twice, 2 goes in here 5 times. There's 1x on the top and there's 3 x's on the bottom. So this 1 is going to cancel with one of those, and there's going to be 2 left. So what we have here is on the top we're left with a 5, and on the bottom we're left with a 2 and an x squared. And that's the answer on that one. So finally good that we could simplify one. And then let's take a look here. So f times g of x on this one is going to be, if I wrote 6 to the x times 7, we would normally put the 7 as a coefficient out front. So I'm going to write 7, and you can kind of see why we do put those in parentheses. So there's the answer on that one. And then we would have f on the top, g on the bottom. And we're going to do, let's see, 6 to the x, and we're going to divide by 7. And there's nothing that we can do to simplify that one, so we're done right there. Again, just kind of keep in mind that when we do a division problem, we do have to make sure that we're not dividing by 0. But since that's a 7, we don't have to worry about that at all. And I don't think there's any on your assignment or on the test like that. Not too worried about domain issues right now, just kind of keep those in mind. Okay, let's take a look at this other side right here. This is where we're doing those operations with functions, and then we're actually evaluating it for a particular value. So in this case, we're going to plug in a 3 or a 7 or whatever it happens to be. Make sure we pay attention to the order that these come in. We've got 3 different functions to choose from. Remember, there were 2 different methods for this. One was we could plug that value into each one of the functions, then do the operation. The other one was we could do the operation with the functions, simplify it, and then plug in that particular value. So plug in a 3 or a 7 or whatever it happens to be. I think most people agreed that this is easier if we just evaluate each one of those functions and then do the operation. So let's go ahead and do that one on this one. We're going to find f of 3, and we're going to find g of 3. So f of 3 is going to be 3 times 3, so that's going to be a 9. And g of 3 is going to be 4 times 3 plus 2. So that's going to be 12 plus 2, that's going to be 14. And all we're supposed to do here is we're just supposed to add these together. So if we add those together, we end up with 23. Circle it and we're done. So f plus g of 3, if If we wanted to write it down here to make sure that everybody understood we knew exactly what we were doing, this is how we'd write it. Okay, let's take a look at this one. This is g times h of negative 2. So let's find g of negative 2, and let's find h of negative 2, and then we're going to multiply those together. So g of negative 2 would be 4 times negative 2 plus 2, and h of negative 2 would be negative 2 plus 6. So let's see what we get here. This one's a 4. That one's pretty easy. And then if we multiply here, we get negative 8. Negative 8 plus 2, that's going to be negative 6. And we want to multiply those together. So we're going to have a negative 6 times a 4. We end up with negative 24. There's our answer. So g times h of negative 2 is negative 24. Okay. All right. F minus h of 7. So let's find f of 7. Let's find h of 7, and then we'll do a little subtraction problem. If we plug in a 7 into f, this is going to be 21, minus a 7 into this one, that's going to be 7 plus 6, that's going to be 13. So we get 13 here, so we end up with 8. So there's our answer on that one. And then here we're going to have h of negative 2 on the top, and we're going to have g of negative 2 on the bottom. Let's see, so h of negative 2, let me just change this here. So we're going to plug in a negative 2, so this is going to be a 4. We're going to plug in a negative 2. Didn't we do that already? We did. We found out that that was negative 6. And then we want to simplify that just a little bit. That is going to be negative 2/3. Okay? All right, let's slide down here and take a look at what we've got left on this. It says put all 3 functions into a graphing calculator and sketch the graph. Label at least 3 points on each one. So when we go through and do this, we did this in a couple of sections ago. I think it was 7.6. I'm going to make this smaller so I can see it all at once. Let's go ahead and plug this in here. So we're going to do y equals, let's see, x to the second. So we're going to hit x, raise that to the second power. And I'm going to go ahead and graph this because it does want us to label these, and this might get a little bit messy. So I'm going to hit graph. Whoops. Common mistake. We've got this ugly picture right here. I have no idea what this looks like, so we're just going to hit zoom and 6. That'll snap back to the nice negative 10 to 10 in each direction, the standard window, which is pretty close to what we've got right here. I'm going to hit trace. 0, 0 is a point on the graph, so right there. And then we'll come over here. Again, we get those decimal values, so I'm going to do this. I'm just going to type in a 2. We get a 4, so we're about right there. And then let's come over here. Let's say I do negative 3. Negative 3, we get 9, so back 3 would be up here right there. And we get kind of this nice gentle U shape. So it looks something like this, again, because I'm right-handed and I want to see this whole thing. Okay, well, that doesn't look very good. Okay, it doesn't even come down there and touch. Okay, so it comes down here, goes like that, and then goes up like this. Okay, all right, not too bad. So this point right here was 2, 4. This point right here was 0, 0. And remember that point right there was 3, 9, negative 3, 9. Oh, and look how ugly that is. I really ought to make that look better. Okay, come down here, hit right there, and then we want to make it hit that point. Okay, that looks a little better. I feel good now. Okay, let's see. Let's take a look at this one. So we're going to come back to the y equals menu. I'm going to turn that off. Because we do want to eventually put all these on the same one, and we're going to do parentheses 5 divided by 2. We're going to raise that to the x, and then it says minus 8. So let's see what that looks like. We'll go ahead and hit graph. Okay, so this is an exponential shape. I mean, we have a base that's a number, and then the variable is in the exponent, so that is an exponential. You'll notice that it's down here, so I'm going to go, oops, I should hit trace first. So we hop on there, see the cursor on there. You'll notice what's happening the further I go out here. Notice how it's just getting closer and closer to negative 8. Okay, so we could just keep going out there. So we've got a horizontal asymptote at negative 8. So it's going to go along here like this. And I'm just going to write y equals negative 8 for our asymptote. And then let's plug in a 0. We're already on trace, so I'm going to hit 0. Okay, so that's negative 7. Okay, and then let's go to 1. Okay, that's negative 5.5. So negative 5.5 would be about right there. All right, and let's label these right now. So this is 0, negative 7. And then this is 1, negative 5.5. And let's see if we can find where that crosses. Let's see, that's positive and that one's negative. So somewhere between 2 and 2.3. Let's type in a 3 and see what we get here. So at 3, we're at 7.625. So 3 and 7.625. So about right there. Okay, so the graph looks like this. Comes down here, really steep, and then flattens off really quickly, heads out there, and gets really, really close to -8 as it approaches -infinity. Okay, put an arrow on that one. If we did want to find that x-intercept, remember how we do that? We're going to hit second calculate. We want to find the 0. We want to find where the x... Whoops, let's see what's going on here. Oh, let me go back and change this. We need to hit, I hit value. I wanted to hit number 2 for 0. There we go, left bound. So remember, we want to get on the left side of where we think it crosses the x-axis. And then we want to get on the right side of where we think it crosses the x-axis. Okay, and remember, what we're finding here is we're finding the point where it crosses the x-axis, so the y-coordinate would be 0. So it says take a guess. It says about 2.27. So 2.27. Okay, put a decimal on there. All right, last one. And again, this one shouldn't take any effort at all. I'm going to go up here, turn this one off. Come over here, we're going to type in 2x and then plus 3. Okay, so this one should cross at 3. We know that's a linear function right there. We're going to rise 2 and run 1, rise 2 and run 1, so it looks something like this. Okay, so we've got a nice graph like that, and gosh, I hope we get this right. This one crosses at 0, 3. Whoops, 0, 3. That point right there would be 1, comma. Let's see if we went over 1 and we're at 3, this would be 4 and 5, so this would be 1, comma 5. And let's get that point right there. You can kind of count your way to that one. That one's -1, 1. And then I am going to put a little point right here for the the x-intercept. But let's see if we got this right. So let's just go ahead and hit graph. Looks pretty good. We're going to hit trace. 0, 3, we got that one. Let's type in a 1. We get a 5. We're good there. Let's type in a -1. We're good there. Okay, so that's awesome. And now remember, to find the x-intercept, we're going to hit second and calculate. We want to find a 0. We want to find where the y coordinate is 0. So we hit number 2. And we make sure we're on the left of where we think it is. This is definitely on the left side of that point, so we hit enter. We want to do on the right side of where we think that is, definitely on the right. And you can tell because it puts those little arrows pointing to the little interval on which it's going to find that. You don't have to guess, but if you want to, go ahead, and it says 1.5. So -1.5. Okay, we're in good shape there. Then it says state the domain and range for each one of the functions. All right, so domain and range. Let's see here. The domain for this one, you can plug in anything you want, squish it onto the x-axis. So this would be -infinity to infinity. The range, though, we don't get any negative values. We do get 0, though, so we're going to start at 0 and go all the way to positive infinity. For this one here, again, this is an exponential. Whoops, so the domain, let me put a D right there, and then an R for range. The domain, you can plug in anything you want. It covers everything with the negatives all the way through the positives, so -infinity to infinity. Certainly no domain issues right there. And then the range, if we squish this onto the y-axis, it starts covering the y-axis right here and goes all the way up there. So this is going to be from -8, whoops, make that look like a -8. -8 to infinity, kind of get carried away with those lazy 8s, sideways 8s for infinity. And then remember, it doesn't actually equal that because this asymptote right here just approximates the graph. It never actually touches -8. And then, of course, for the linear function right here, that's going to be from -infinity to infinity for the domain and from -infinity to infinity for the range. Okay, and determine whether the linear, exponential, or something unfamiliar. Just like when we did this before, this one is unfamiliar. Unfamiliar. Okay, that actually is going to turn out to be a shape called a quadratic. It's called a parabola, but you'll be studying those next year. This one is exponential. Exponential. And this one is linear. And then it says, of the three functions above, which one grows the fastest as x approaches infinity? So again, out on the right end. So let's go ahead and take a look at this and see what we've got here. So I'm going to hit y equals. We're going to turn each one of these back on. And we're going to take a look at see what they look like all together. So we've got, they're going to be graphed in order. So I'm going to hit that. There we go. The line was already on there, so that's why that was there. Okay, so if you take a look here, these all look like they kind of merge right there. So let's change the window. Let's go from 0 to 10. And then we don't need any negative values. We're interested in what happens out here, and they all tend toward positive infinity. So we're going to go from 0. Let's go up to 100, and let's see what happens there. Again, if I don't change the scale, it's going to put 100 tick marks from on the y-axis. We're going to get a really fat-looking y-axis, but that's okay. And I was talking there, so let's make sure we pay attention to this next time. I'm going to go back in here. I'm going to hit the window. And I'm going to change that to a -5 or something. We'll hit graph. Okay. All right. So here was the order. 1, 2, 3. So number 1, this is that quadratic. This is that U type of shape there, that parabola. Okay. Number 2 was this one right here. That was the exponential. And number 3, that was the linear one right here. So the exponential one definitely grows the fastest. But if I hit zoom and I hit 6 again, that's not really the way it looked, because the exponential started down here. It was kind of below all of those, and it had a lot of catch-up to do. But once we changed that, it definitely turned out that way. So the exponential one grows the fastest. So the exponential, and how can you tell? Steepest, biggest function values. Okay, anything like that would be totally okay. All right, now the last part of this, it says solve each system using a calculator and sketch the functions and state the solution. Okay, so we've got a couple of these to plug in here. So I'm just going to leave this like this, and I'm going to clear off each one of those, and then I'm going to come back here and we're going to start typing this in. So on this one, for number 30, we've got -x divided by 2, and then plus 2. And then the other one is 4 raised to the x, hop out of the exponent, and then -10. Okay. Now, again, I always like to hop down here so I can look at them. This is -x over 2 plus 2. Good. And then we've got 4 to the x minus 10. Looks like we're in good shape. Now, to make this a little bit easier, I'm going to go ahead and change the scale on this. So I'm going to change the window. -10 to 10, we're in good shape there. But then we go from -20. So I'm just going to type in -20 to 20. And they put tick marks every 5, so I'm going to go ahead and hit 5 right there. So tick marks every 1 in the x direction, we've got that. Tick marks every 5 in the y direction. At least that's where the major lines are. So I guess if you look at the major lines, I guess we could put it every 2 on this one just to make it match up. Okay, let's go ahead and hit graph and see what we've got. Okay, now this really is not a surprise. This should cross at 2 and have a negative slope, which it does. And we would expect this to be an exponential, okay? So we would expect it to grow like that and grow really quickly. So let's just sketch and see what we've got here. So I'm going to hit trace. This crosses at 2, okay? And then it has a slope of -1/2. So this would be down 1 over 2, down 1 over 2. So it's going to cross right here at 4. So about right there. Okay, so it's going to look like, we'll just make it look like that. Okay, so there's the line. And then we've got the other one. So let's see, let's hop onto that one. So we hit the down arrow. -9 is where it crosses. Okay, and then as we go out here, notice that the values get closer and closer to -10. So what we've got here is we've got an asymptote of y equals -10. Whoops, y equals -10. So it's going to run along here, and then it's going to run into that one. Now, we actually want to find that point of intersection. So remember, calculate. We want to find where it intersects, so 5. First curve, yes. Second curve, yes. If you want to take a guess, those are pretty far apart, so we could go ahead and do this. Hit enter, and it's going to tell us 1.73, or that would be 1.74, and then 1.13. So we're going to make this get really steep here, so kind of like that, okay? And it's going to intersect, and the point of intersection is going to be 1.74, comma, 1.13. Okay, so there's the solution. So maybe I ought to write that over here, 1.74, comma, 1.13. Okay. All right, so we've got that one taken care of. Again, enough of a sketch that you can kind of tell what's going on and that everything looks good. So let's go ahead and take a look at the next one so we can clear this off. We're going to clear there and clear here, and we're going to type in, this is 1/2 raised to the x. And then the other one is, oh, we've got to change this around just a little bit. Okay, let's see what we've got here. So we're going to subtract 2x. So this is going to be -3y and -2x minus 8. And then we're going to divide everything by -3. Whoops, -3. Okay, so here's what we've got. We're going to have y equals, this is going to be 2/3 x and then plus 8/3. So let's go ahead and type that in. So we're going to have 2. I like putting the x on the top, and then we'll divide by 3, because remember, that's really where it is, if you think of that as over a 1. And then we're going to plus 8 divided by 3. So again, hop down here, make sure this looks like right. We've got a 1/2 raised to the x, yes. And then we've got 2x divided by 3, 2/3 x, and then plus 8/3. So we're in good shape there. So I'm going to hit zoom 6. Okay, so this is one of those exponentials that comes down from left to right. Instead of getting bigger, it actually gets smaller. So I'm going to do this right this time. This window looks pretty good. There's no scale on this, so we'll have to add some numbers over there. So I'm going to find the intersection point first. So we're going to hit second calculate, and we're going to hit 5. And we're going to say, yes, that's the first curve. Yes, that's the second curve. No guess. Oh, hey, look at that. It turns out to be a nice point. So I'm going to mark on here -1 and then 2. So they're going to cross right here. And we've got a graph that comes down and basically gets closer and closer to the y-axis. So there's our asymptote. So it's going to come down like this and then like that. Okay. And then this one, let's see, where does it cross the y-axis? So I'm going to hit trace, and we're on the first. Oh nope, we're on the exponential. Now we're on. I hit the down arrow or the up arrow. We're going to be on the other one. Now it crosses at 2.6 repeated. So that's 2 2/3. That's that 8/3 there. Okay, so it's going to be about right here. So this is what it would look like. Okay. And that solution point, okay, I'll draw a little arrow over here. Remember, that solution point was -1, 2. Okay, that was our answer on that one. Okay, so we've got a couple things labeled here. Let's go ahead and do 1, 2, -1, -2, and this would be 1, 2, and 3. And just for the heck of it, looks like that one crossed there. Let's see if it does. So let's hop back onto that exponential, and look, it crosses right there at 0, 1. So we're in good shape there. Okay, lots of stuff going on there, lots of really good practice with each one of these types of graphs and working with these functions. Good luck on the assignment as you practice for the test, and good luck on the test.